Assalamualaikum and very good evening to all of you. Welcome back to the class of BAA2213, the Reinforced Concrete Design 1. Okay, in this video I will discuss the exercise number 9, which is still the shear reinforcement for rectangular section beam. Okay, rectangular beam section. Okay. Okay, I hope you can see my screen. Okay, let's do it faster. Okay. Okay, for exercise number 9, the situation given is just like the exercise number 8. 9, okay, where the span still equal to 6 meter. The beam with the ultimate UDL, now I increase to 160 kilonewton per meter. Okay, I increase the value of ultimate load, and then the rest will still similar. Okay, the B is still 225 mm, D is still 500 mm, FCK is still 330 Newton per millimeter square, FYK is still 500 Newton per millimeter square, and then the still for AS prime is equal to 2H16 equal to 402 mm square, and AS is equal to 6H20 equal to 1880 millimeter square. Okay, so the solution, anybody can give me the solution? Just like the exercise 8, so we check the design shear force. Okay, VED equal to WL over 2 equal to, now our W, our ultimate UDL is equal to 160 times 6 over 2. So what is the value of our VED now? Okay, anybody has the answer?
480.
Okay, thank you. 480. Anybody has the answer? Just unmute your microphone and speak it. Okay, speak tell me the answer. Okay, so we can have a faster time to settle. Okay, then we check the strut. Concrete strut. Check the concrete strut capacity. Okay, so the equation is still similar. How to check is equal to 0.36 BW FCK times 1 minus FCK divided by 250. So divide by cotangent theta plus tangent theta. So we have to check first we have to check if theta is equal to 22 degree, the tangent theta is equal to 0.4 and cotangent theta is equal to 2.5. So we just similar as the previous one. So the value of previous one is equal to 369 kilonewton, right? As in equation exercise number 8. So this one, however, for this one, our VED is larger. VED is larger. So if this situation happen, okay, let me show you. Okay, like as this one. Okay, our VED is larger than VRD max for 22 degree. So we check for 45 degree. Okay, so if we check the theta equal to 45 degree, so the tangent 45 degree is equal to 1, and cotangent 45 degree also equal to 1. So VR the maximum is equal to 0.36, okay, times 225 is our B. Just fill in the equations, okay, is the relevant value. 500, our FCK is 30, so 1 minus 30 divided by 250. Okay, so cotangent theta is 1 plus 1. So what is our VRD max now? Any answer?
535.
Okay, thank you. 535 kilonewton. So now we can conclude. So our VED is equal to 480 kilonewton. So and is greater than VRD max for theta equal to 22 degree, but it is lesser than VRD maximum for theta equal to 45 degree. So this example is go into solution number, okay, to this one. Okay, let's say this is number 1, this is number 2. So it goes to the situation number 2. So we must design shear reinforcement, but first we have to find the value of theta. Okay, this is the difference, the difference between example 8 and example 9. So we have to design shear reinforcement, but theta is greater than 22 degree. So we don't know the value of theta yet. So we must, the additional step is to find the theta. Okay, so we find theta equal, okay, by using these equations. Okay, these equations, okay, you must use your what to say, your calculator. Okay, because we have to use the function of anti-sign. Okay, theta is equal to 0.5 anti-sign this one. Okay, VED divide by 0.18.BW times D times FCK times 1 minus FCK divide by 250. Okay, 0.5 anti-sign VED. Okay, our VED is 480 times 10 to the power of 3 divide by 0.18 times 225 times 500 times 500, 1 minus 30, 250. Okay, take your time. Okay, please tell me the answer. Okay, 0.5 anti-sign. Okay, what is the answer? What is the value of this? Okay, anybody have the answer? Okay, what is the value for this calculations?
32.
Sorry, 30? 32. Okay, good. So this one is equal to 0.898. Okay, you want to use the theta is equal to 32 degree. Okay, so you use theta is equal to 32 degree. Thank you. So now next step is just like example exercise number 8. So we just design shear reinforcement, but according to theta equal to 32 degree now. So our cotangent theta is equal to what, and tangent theta is equal to what? Cotangent is equal to cos divided by sine. Okay, can you find the value for me? Cotangent theta, what is the value? Cotangent theta now?
1.6.
1.6. Confirm, okay, 1.6. Tangent theta?
0.6.
0.6. Okay, thank you. So the ASW over S is equal to BED divided by 0.78 times D times FYK times cotangent theta equal to VED is equal to 480 now. 0.78 times 500 times 500. Our cotangent theta is 1.6, so 1.6. So what is the value of ASW over S?
One point 538.
Sorry, 1.538.
538.
So 1.538 macam ni Okay lah. So spacing. Okay, let's say we use H10. Okay, what is the value of ASW? Assume 2 number of bar. Use H10. It's okay. In the final exam or special exercise, we use the diameter of bar shall be given. Okay, shall be given. Okay, what is the value of ASW now if you use H10? Okay, can you check for me from this table?
283.
283, sorry. 283. Sorry, this table is differ from the last I show you. This is the bar size is to the vertical. Okay, the column is the number of bar. This is the number of bar size. 10 is here. Okay, row number 4.
157.
Okay, good. 157. Okay, 157. Okay. So SW is 157 millimeter square. So spacing S is equal to ASW over 1.54. Okay, this one 1.54. So it's equal to 157 divided by 1.54 equal to any answer? 157 divide by 1.54.
101.
101 mm. So what can you propose? Use S equal to
100.
okay, good. Thank you. 100. So you use H10 100 millimeter center to center. This is the near support. Okay. And then we check the S max is equal to 0.75D just as previous 0.75 times 500 equal to 375. So okay lah. Okay, because our spacing is not exceed the limit. So we check the design minimum length. Okay, as usual, we design the minimum length. Number 4, step number 4 is we design the minimum length until we have to find the X. Okay, ASW over S is equal to 0.08 BW dot FCK. Okay, just like exercise number 8. Okay, so you enter the value is equal to 0.2 here. So we can still try H10. Okay, ASW is equal to 157 mm square. So spacing S is equal to ASW divided by 0.2. So may I know the answer of new S at the midspan? Any answer for our S?
785.
785, okay. 785. So 785 mm square. This is greater than S max. So we limit our spacing to the S max. S maximum is equal to 375. So we may propose H10 350 mm. Center to center, this is near the midspan. Okay, so check the shear resistance. Okay, shear resistance of minimum link. V minimum is equal to ASW over S times 0.78 D FYK times cotangent theta is equal to 157 divided by 350 now the S, and then 0.78 times 500 times 500 times cotangent theta 1.6. So what is our V minimum now? Okay, anybody have the answer?
One four zero kilonewton.
1 point? Huh?
140.
140. Okay, kilonewton. Good, thank you. Okay, so we find the value of X. Dah habis lah. Okay, sorry, I have to use this blank page. So find the distance of X as in exercise 8. Okay. This is 450. This is 140. So here is our X. Here is the Y. And here is L over 2. So the value of X is equal to 480 divided by L over 2 is equal to Y over X. So 480. Okay, 480 divided by 6 over 2 equal to 480 minus 140 divided by X. So what is the value of X now? For 0 times 3 divided by 450, 480. So X, what is the value of X?
2.125.
2 point?
125.
125, okay. So it's acceptable. 2.125. So next step is additional, okay, check additional tension force. Additional longitudinal reinforcement, okay, longitudinal. Just 5 steps actually, okay, for rectangular reinforcement. So additional tension force FTD is equal to 0.5 times VED times cotangent theta is equal to 0.5 times 480 times 1.6. What is the answer? Okay, anybody have the answer?
384.
384.
384.
Okay, thank you. So this one. Additional tension reinforcement. AS is equal to FTD divided by 0.87 FYK. So 384 to the power of 3 divided by 0.87 500 is equal to
883.
3 mm square. So because our steel arrangement is still similar to exercise 8, so we can use 4H20. So AS is equal to 1260 mm square. Okay, so the detailing will be like this one. Just similar step as in example 8. Okay, you just draw the concrete beam and concrete column as a support. Okay, this is just a free sketch. So okay, so this one. Okay, at the top bar we have 2H16, and at the bottom bar we have here as additional tensile reinforcement near the support. Okay, here we have 4H20, and here at the middle midspan after curtailment. Okay, before curtailment. Okay, this is at the top is 2H20, and at the okay, this one is our link. This is also our link. This is H10 berapa tadi? Tak ingat lah. H10. Anybody can check for me? So this one, okay. At the middle we have 350 tadi kan? At the middle we have 350. Okay, here at the midspan. And at the support we have 100. Okay. Okay, H10 100, and this one H10 350. At the near support it will become closer again, H10 100. So our value of X is here to here. X is equal to 2125 mm. This is also 2125 mm. Okay. So if you have two cross section, okay, two different cross sections. So let's say this is x1 to x1. So near the support you have your design like this one. Okay, the cross section. This is x1 to x1. You have the top reinforcement here. You cross this. You imagine that you cross. Okay, this section. So at the top you have here. Okay, 2H16 at the top, and at the bottom you have 4. 1, 2, 3, 4. 4H20, and as the shear reinforcement you will have, okay, this is your shear reinforcement. Okay, loop. You will have the shear reinforcement here is the H10100. Okay. However, if you cut another section at the middle here, let's say X2 and X2. Okay, at the middle here you have, okay, you cut here. Okay, you will have the similar size of section, similar size of beam. Okay, X2 to X2. So you have at the top is 2H, still 2H20, 2H16. Okay, still similar to H16. 2H16, and at the bottom here 1, 2, 3, 4. Okay, because here you can see the is you cut here, you still have the 4, and then another additional of 2 reinforcement at the top. Okay, let's say this one here and here. So if you are working as site engineer, or maybe you start, okay, join you have an internship with contractor, and they ask you to check the steel reinforcement. Okay, make sure you can check the steel reinforcement before concreting, because sometimes maybe because the detailing is quite complicated, maybe the workers miss 1 or 2 steel bars, so you have to check, and if the steel bar is not tally with the drawing, you may ask the contractor to repair the reinforcement before concreting job. So this is 2H16. So the link here is H10 350, and here is 2H20 plus 4H20. Okay, any questions up to now? Any question, class? Okay, I have if you not have questions, so I have questions. Okay, so this one. So I have homework for you. Please submit before our class. Okay, exercise 8A to 8D only. Okay, exercise 9A to 9D you submit before Monday. Okay. Okay, 8A to 8D. This is based on, okay, this is the questions. Okay, the questions is based on text. Okay, I will never, I never give you the like this one, this is point. Okay, if you have got question this one, this is heaven. Okay, this is point, this is in term of point, so it will be easy for you, but this is not your level. Your level as a degree, bachelor degree, is as an engineer. You must be able to read the situation, analyze the situations, and then extract the point before you solve the problem. 8A to 8D, and I have a question 9A to 9D. Okay, 9A to 9D you submit before our class next week lah. Okay, before Monday pun okay. Okay, 9A to 9D. Okay, sesama je. Okay, so pusing-pusing je. So 9 is you refer exercise 9. Okay. Okay, any question class before we dismiss? Yang perempuan mungkin nak masak. Okay, thank you.